We will be presenting today Hardy-Weinberg Equilibrium Introduction. So for the Hardy-Weinberg Equilibrium, it's important to have a large population size. And since we have such a small population size, genetic drift may occur. We only have 5 flies for each phenotype. Since the population size is so small, the allele frequency will change and go in either direction.
Now we will be getting into the background on the organism, specifically describing the phenotypes of our flies in the context of Hardy-Weinberg equilibrium. So, some background on the organism's phenotype. In our population of flies, we have red-eye flies, which are the wild type, and we have white-eye flies, which are the mutant type. In our population, our phenotypes should stay in equilibrium if ideal conditions are kept. We will not be keeping ideal conditions. In relation to Hardy-Weinberg equilibrium, as I said, our phenotype should stay the same under ideal conditions. These are the ideal conditions, but we will most likely see genetic drift because of our small population size.
Don't be doing this now. Our actual hypothesis, research hypothesis. So our small population size that we have is more red-eye flies after 6 to 7 weeks compared to white-eye flies. Our null hypothesis is no change in the allele frequency will occur between the red and white-eye flies. The phenotypic ratios and differences. Because population size is small, genetic drift will occur, and one of the phenotypes will likely shrink while another will grow. We predict our phenotype ratio will be more red-eye flies than white-eye flies. The differences between the flies will be obvious because of the eye color.